All right, guys. You'll notice that on the sheet we're going to talk about exponents. You've been exposed to exponents in the past, but pay attention to our little conversation here instead of being on your phone right now. Yeah, that's you. Coefficient. There's a coefficient of an exponent. That's the number out in front, or a power. Okay. We have the base of an exponent, which is the thing that's raised to the exponent, and then we have the exponent itself, which is the 5, the little number in the top right. These two numbers, the coefficient and the power, need to be treated differently because they're in totally different locations. Okay? Today what we're going to do is we're going to investigate how those are going to be treated differently. Okay? Specifically how to multiply things called monomials. All right. When you're doing these, we're going to investigate this based off of something that you've already done before. So let me just give you a heads up right now on how to do it. Then you're going to complete the tables with your row partner, okay, and go from there. Like for instance, if we're going to complete this table. Notice this first line. If we have 7 to the third times 7 to the second, okay, that's this first expression. That is the same as doing 7 times itself 3 times, because that's literally what an exponent is. 7 times itself 2 times and multiplying those two groups of things. There are a total of, in that set, there are a total of 1, 2, 3, 4, 5 sevens. Okay? There are a total of 5 sevens. In addition to that, that exponent is 3. And this exponent is 2. When you add 3 plus 2, you get that same number 5, which is a very nice pattern that we can actually create a rule for in the end. That's where we're going. We're going to create a rule by the end of the day so that we don't have to do all this long work for all these long problems. Okay? Right now, if you notice, 3 plus 2 was 5. We said that. That's going to give us the base 7 to the 5th power. 5 comes from adding the exponents. With me? It also comes from counting the amount of bases that you would multiply together. Let's look at the second table. This set. What happens when there's coefficients? That's the new question. We group the coefficients together. 7 times 2. We just treat those like regular numbers because they are regular numbers. They're coefficients. They are not exponents. Then we group the expressions from the exponents together. There are 3 x's from that first group. There are 2 x's from that second group. If you count them up, there's 1, 2, 3, 4, 5 total. 5 total factors. Okay? And at the same token, if you add these exponents, 3 and 2, 3 plus 2, we get that same number, 5. Okay? So again, we get the 14. When we finish multiplying these, we get this 14 from the 7 times 2, from the coefficients, and we get to x to the 5th, this x to the 5th. We kept the same base x, and we have a new exponent 5 from 3 plus 2. Okay? With your row partner, go ahead and fill out these tables. Okay? Ask them questions to clarify it, and we'll go over these in a second. I'm going to play one song. And then after the song's over, we're going to get it done. We're going to talk. Okay. On this next one, you have 2 to the 4th times 2 to the 4th. For this section, you have 4 2's. For that section, you have 4 2's. When you count them all, there's 8 total. Okay. When you do that, then you can also add 4 plus 4, which is 8. Which then becomes, we keep the same base, and we just write 4 plus 4. Okay. Next one. how many versions of each base. There is a total of 9 x's right now, and there is a total of 2 y's right now. Just for the x's, the sum of the exponents, 4 plus 5 would be 9. Those are similar. And there's just 2 to the y. There's only 2 y's. And a final expression becomes x to the 9th, y to the 7th. Now we don't add those two your 1 5